Thanks for joining our monthly community webcast. I'm Jürgen Kress, part of the Oracle Integration Product Management team supporting you as a partner. In case you missed one of our webcasts, on-demand recordings are available. For details, please see our monthly community newsletter. In today's presentation, Anthony Winoots will talk about extreme scalability and enhanced resilience. Good morning, Anthony, and thanks for presenting.
Hey, thanks for inviting me, Jürgen.
Please feel free to post your questions via the conference FAQ or use Twitter #PaaSCommunity. At the end of the webcast, we will answer your questions. Slides are available at the community workspace. Please do not tweet and blog about products and services which are available today. Please do not blog about roadmap and future services. OIC connects SaaS services like CX, HCM, and ERP. Therefore, it's often business critical. Objective of the call is to ensure that your Oracle integration project scales and is highly available. This month, Anthony published a white paper configuring a disaster recovery solution for Oracle integration. He's also the author of the SOA Suite Developer's Guide. So let's get started. I will kick off the call with the community announcements and hand over to Anthony. We will wrap up the call with the call to actions and to answer your questions. We will give you an update first with the customer announcements, and then in the second section, I will talk about announcements for you as a partner. Anthony, you published a white paper this month, which is called Configuring a Disaster Recovery Solution for Oracle Integration. Can you talk a little bit about the white paper that is now just available?
Yes. So we have a lot of requests from customers who want to be able to set up a business continuance or disaster recovery configuration across 2 OCI regions. We are currently working on providing a completely Oracle managed solution for this, but in the interim, we've provided a customer managed solution which allows a customer to provision a second OIC instance and then to synchronize their metadata between the primary and the secondary. At the moment, we are limiting this to just select customers. So if you want to share it with a customer, please reach out to Oracle Product Management and Jürgen can help you connect with people. And this is because there's a few wrinkles in the white paper today that may require some additional assistance. So in theory, everything can be done by the customer, but we found that some customers get a little confused, which is why we're sharing it with you, our partners, rather than directly with the customers themselves. So please, if you're going to share this with a customer, please get approval from Oracle Product Management, but you're welcome to read the paper yourselves and see how it sets up. Thanks, Jürgen.
Excellent, thank you. So we do have a webcast for customers coming up March 2nd. It's 9 o'clock Pacific Standard Time, US time zone. And product management team, Simone, Arvind, Neil, who is also on the call, and Anthony will give you an update on the February release and also talk about the future directions of the May release. It includes some demos like Oracle Insight and the new API-led demo. So make sure you invite your customers to register. March 2nd, the webcast will take place. We would like to say thanks to all the Gartner reviews from our customer base. Oracle Integration Cloud Services rated 4.4 out of 5 stars. If you have implemented successful Oracle integration, please ask your customers to submit a peer review, which is available at gartner.com/reviews. With that, I would like to update you on the partner activities. So if you miss one of our community webcasts, we created a channel at the Oracle Video Hub. There you can see the latest community webcast and some product announcements. Please subscribe at bit.ly/subscribe-community. We will run a joint activity with the hospitality team. Hospitality solutions like Opera require some integration within Oracle SaaS, third-party solution, and on-premise solutions. And the team has built a solution called OHIP, which you can connect easily with Oracle SaaS. So please join the hospitality team for their Innovation Week, March 22nd to March 25th. As the demand is high, we are offering additional hands-on bootcamps to become an expert in Oracle Integration Cloud. Those 3-day workshops will take place in South America, March 16th to 19th in Portuguese, March 30th to April in Spanish, and we offer a workshop in English, EMEA time zone, April 6th to 8th. Registration will open with the next community newsletter. And our next community webcast will take place March 30th, 4 o'clock, and we will have Louis Weyer as a guest talking about OHIP and Oracle Integration Cloud together with Neil. Registration is open at bit.ly PaaS Webcast March 2021. If you would like to learn more about our upcoming events and activities, please make sure that you subscribe to our newsletter. The February edition is available with all product information, specifically the February release, and also technical articles. With that short introduction, I would like to hand over to you, Anthony.
All right, thank you, Jürgen, and thanks for all the great work you do with the community. You are absolutely the best community outreach for partners, and you do a grand job. So what we're going to talk about today is some of the sort of scalability and performance capabilities within OIC. And so what we'll do is we'll start off by talking about a few examples. So we have 2 extreme volume examples to talk about. And then we'll talk about some of the patterns that enabled these customers to reach very high volumes. We'll look at it both from sync and async perspectives, from scheduling, and from things that we can do to improve performance of our integrations. So with that in mind, let's start off by talking about a customer from Latin America. This customer has around about 5 million registered users for their mobile application and their loyalty system. And so they rolled out a mobile application that would enable a customer to check their loyalty points and also to be able to redeem those loyalty points for free product. In this case, they were using Oracle Loyalty Cloud as their back-end system of record. They also tied in their point of sale applications to be able to validate that the customer had the loyalty points available and then to deduct the loyalty points when they got a free gift. Now, those 5 million customers, a large percentage of them would reply within a couple of hours to text messages that were sent out with the latest offers from the customer. And so this put a huge load on the system, and we would see up to 1 million messages an hour coming in. They had deployed a synchronous integration, a request reply integration that made multiple calls to Oracle Loyalty to manage the points. And so typical response times they were looking for was less than 3 seconds. And in fact, if the point of sale didn't get a response within 6 seconds, it would send out the call again. So it was very important that we got low latency and high throughput. Now, you've probably noticed that 1 million messages an hour is significantly more than the 60,000 messages an hour that you can configure through the user interface in OIC. It is possible to configure larger environments, and we'll talk about that in a following slide. So this customer has now been live for just over a year, about 14 months at this point. And of course, their timing was terrible, unfortunately, with the pandemic. And so we saw the 1 million messages an hour when they went live for a few months, and then it dropped off dramatically. And I'm pleased to say that perhaps things are returning to normal, as I did check on their numbers. And over the last month, they have been bouncing up and hitting 1 million messages an hour again. So hopefully they're recovering from the pandemic. Another customer, it was in North America, which is an online online web store. So they have their own web-based order capture application that takes orders from customers directly over the internet. And they then push those orders into their fulfillment system. The fulfillment system is Oracle Fusion ERP. In this case, we talked with the customer before they went live and agreed with them that their best approach would be to have an asynchronous orchestration. So this is a fire and forget capability. It turned out that this was extremely valuable because when they switched over, they had around about 600,000 orders arrived in the first 40 minutes of the system going live. This was partly because they'd stopped the old mechanism for taking the orders, and they were backing up in the order capture application. So as soon as the new system came online, it was immediately hit very heavily. So we had 600,000 orders in 40 minutes. This load exceeded the capacity of Fusion ERP. Fortunately, OIC automatically queues asynchronous messages. And so in this case, we had literally hundreds of thousands of messages queued up in Oracle integration. And at the same time, poor Fusion ERP was processing large numbers of orders per minute in order to clear the backlog. And the combination of Fusion ERP and the queuing in OIC ensured that no messages were lost, although it did take 3 to 4 hours to process all the messages. And again, to reiterate, this was a peak that was kind of unexpected. You know, they'd backed up a bunch of messages in their order capture, and then when they turned the system live, all those backed up messages arrived within at once, or in this case, it took 40 minutes for the order capture application to push them into OIC. So again, this was far more orders, and in this case, far more messages arriving than they'd actually got message packs for. However, we were able to queue them successfully and then process them a few messages at a time so that we didn't overload Fusion ERP. So with that in mind, let's review some of the behaviors and talk about how those impact performance and scalability within OIC. So first of all, we have synchronous behavior. This is any app-driven orchestration that has a response configured for it. If it has a response, it's going to be synchronous. So the messages are queued internally, but it's a very short queue, and the idea is that they don't live there very long. And they are executed immediately. We have concurrent execution. And so the level of concurrency depends on the number of message packs. And so for the first customer we talked about, they had a large number of message packs, and that corresponded to a large concurrent execution capability. If the messages arrive faster than there's ability to execute them, there is a small, short-lived backlog queue for synchronous requests. And typically, we don't expect messages to live in that backlog queue for more than perhaps 30 seconds to 60 seconds. So it is a very short backlog that we keep, because basically the client has made a call and is expecting a response. Let's remind ourselves about the async use case as well, how that behaves. So how do you create async behavior in OIC? You create an app-driven orchestration that has no response. If there's no response, you are automatically going to be async. Now, this is important because async messages are processed differently. As soon as we receive the message in OIC, we immediately reply with a 202 status code, which basically says, I've accepted your message and I will process it when I'm ready. So the caller gets an accepted status. He knows the message has been received. And so this was what was happening with the order capture application in the second customer we talked about. He was putting in thousands of messages a minute, and they were immediately being accepted, queued up within OIC. And as soon as they were securely in the queue, the status code of 202 was sent to say, we've accepted the message. You don't have to worry about this order anymore. So the messages within the queue are processed in order of arrival. However, it is possible for one message to be processed, for messages to be slightly out of order because we have concurrent execution. And so one message might be scheduled to run first, but then the other message might finish faster because it didn't wait as long for downstream systems, for example. So this is a weak ordering in that messages are roughly processed in order of arrival, but they don't necessarily complete in that order. So key things about the async is that there is a very large queue associated with async integrations. All async integrations share the same queue. So this, if you need to separate priorities, if you have very large numbers of async requests coming in for one integration and you don't want to stop processing for other integrations that are also using that queue, you may need to use a second OIC instance for that. So that's async behavior. So now that we know the difference between sync and async behavior in OIC, we'll start talking a little bit more about the scalability of it. So instances are generally scaled to guarantee the message pack throughput. If you increase the number of message packs, depending on the number of message packs that are there, if there's not sufficient capacity to support that number of message packs, we will scale the system. A word of warning, scaling the system takes time. It's not instantaneous. And so this is something that we're working on in a future release to make this pretty much instantaneous. But today, it takes a little while, of the order of perhaps an hour, in order for the scaling to take effect. So it's worth checking perhaps with Oracle if you desperately need something scaled quickly to make sure that that scaling is taking place. Again, I mentioned that we had the customer with 1 million messages an hour. In order to get to that scale, it's necessary to use the either the command line interface or the API to change the number of message packs on an instance. And so it is supported to have more than 12 regular message packs or 3 BYOL message packs, but the only way to actually do that is through the CLI, the OCI command line interface, or the OCI API. And so the reason for this is that if people are trying to scale to that level, and 90% of our customers have a single message pack, and that takes care of all their loads. So we're talking about a small number of customers who have more than 12 message packs. And so we want to make sure that customers don't accidentally provision something larger than they need. And also it gives you as partners the opportunity to shine by saying, well, we know how to do that by using the command line interface or the APIs. Note that the concurrency of async processing, synchronous processing, and scheduled orchestrations is all based on the number of message packs, but it's not necessarily a directly linear progression. The standard configuration is actually significantly over provisioned, so it takes a while before you have to have a lot of message packs before you actually exceed the default capacity that's available to a customer. So what are the key points to help us get performance out of async integrations? Well, first of all, remember that these are fire and forget. So if you expect to have very bursty traffic, async integrations are a great way to deal with it because they have no or minimal impact on the client when they start backing up, because the client continues to get his 202 message accepted. So this is great if you, for example, have a retailer who's doing flash sales. And so we have seen a number of customers who have flash sales where their volumes might be 10x or more above their normal volume. And instead of having to provision additional capacity, they can just queue those messages up. And this allows them to spread the load temporally across time. So you might get 10 times the number of messages in an hour arriving, but it might take you 2 or 3 hours to process them. If that's acceptable, there's no need to necessarily scale up your instance. You can just spread that load out over several hours, knowing that the client thinks that it was immediately received. So that's a key point for being able to scale very large numbers of order capture or fire and forget type applications. And so this was what saved our online retailer in our second example. They had far more messages arrive within the first 40 minutes than they had provisioned message packs for, but they were then able to spread that load over the next 3 or 4 hours so that they didn't overload the back-end systems and they didn't have to provision additional message packs. So let's look at some key points for synchronous integrations. So these, remember, are request reply. Now, one of the anti-patterns that we see is a synchronous integration doing too much. We have seen customers with synchronous integrations with literally hundreds of steps and large repeating loops inside them. Remember that your client of a sync integration is expecting a response. Therefore, you shouldn't be doing too much within the integration because you want to get the response back as quickly as you can, because these are intended for immediate responses. In addition, there is a 300-second maximum runtime on synchronous integrations. If they go longer than that, we will stop the integration and we will send a timed out message back to the client. That's if the client hasn't given up and gone away by then. So what can we do to reduce the load in our synchronous integrations? One possibility is to investigate, can we split it into 2 integrations? Part of it is synchronous and part is async. So the heavy lifting can be put into the async integration, but we can do some immediate work in the sync integration. For example, a common pattern for this is where we need to return a reference to something that we've created, but there might be additional steps after the initial creation that we need to do. In that case, we can do the initial creation in the sync part of the integration, then kick off an async integration, giving it the ID of the object we've created to do the rest of the work, and then immediately return and say, hey, we've created your object and here's the ID of it. So there are tricks like that we can do to try and split our integrations to reduce the time taken in a sync integration. We'll talk about some other things we can do a little bit later that apply across both sync and async. We haven't spoken much about scheduled integrations, but this is another area where customers can scale to extreme numbers within OIC. One of the assumptions that we had within OIC was that scheduled integrations will typically be much heavier and longer lasting than async or sync integrations. Because of this, we more strictly constrain the concurrency on scheduled integrations. And we also, for scheduled integrations, we actually track the load on the back-end system on the OIC servers to see if the load is light, we allow more schedules to run. If the load is heavy, we reduce the number of schedules that are running. Now, just as a reminder, scheduled integrations can be executed in two distinct ways. First of all, they can be executed via a schedule. In other words, run every Friday at 5 o'clock, or run every hour, or run at 15 minutes past every hour. And you can have very complicated schedules. We have a basic scheduling capability through the user interface, which is kind of a wizard-driven experience where you can say how frequently you want it to run. Alternatively, if you want to get funky, like say, I want to run on Tuesday, Wednesdays, and Fridays at 9:15 and 11:30, then you can use the iCal expressions. And so you can enter native iCal expressions directly into the scheduler. So that's the first way and the most common way in which we run schedules. The second way that we can run schedule integrations is through a run now. This basically says execute immediately. So this can be useful if we want to test our scheduled flow. This is a great way to test it, but it can also be a great way to run a schedule on demand. So for example, maybe there was a problem with a schedule and that it errored out, and rather than change the existing schedule flows, what we'll do is we'll just do an immediate run now to update things. So for a given integration, unlike synchronous and asynchronous, which support concurrency for a given integration, only one instance of a given integration will be running on a schedule at any one time. If it runs longer, then the schedule will be queued up, and so you might end up with multiple instances waiting to run because only one of them can be running on the schedule at a time. The same constraint applies to run now, but that is a separate constraint. So in theory, for a given scheduled integration, it's possible to have two instances of it running at the same time. Once having been kicked off by a schedule, and the other having been kicked off by a run now. In both cases, when the time comes or the run now is requested, they are queued for execution. And so if you click run now 3 times, you will actually get 3 instances will be scheduled for execution, but at any one time, only one of them will be allowed to run. And when the first one completes, the second one will run. When the second one completes, the third one will run. And the same goes for integrations kicked off via a schedule. So this allows you to have singleton behavior within OIC. And so that's another use for run now, is to use it to create singleton integrations. Schedule performance. Some concerns we have is very, very long running schedules. Generally, it's not a good idea to just keep the schedule running forever because it's potentially stealing resources from other integrations. And so if possible, reduce the amount of work that the schedule is doing. If there's too much perhaps to do in a single run, allow it to only process part of the data and leave the next set of data for the next run of the schedule. Alternatively, you can pass off some of that work to async or run now integrations. This allows you to exploit some parallelism. And it also allows the schedule to go back and be automatically rescheduled to run again. We have an anti-pattern that talks about this in the documentation, the scheduled job that never stops trying to process. So again, for schedules, try and limit the amount of work that's done in them. If you can, break things off into asyncs to to get parallelism. Of course, you can also improve the performance by using the parallel looping capabilities, and we'll talk about those in a later slide. So what can we do to improve performance? One of the biggest reasons performance can be slow is that customers have used an orchestration loop when they could have used an XSLT transform loop to get the same result. The transform loops run hundreds to thousands of times faster than an orchestration loop. So if at all possible, move your looping inside your transformations. Obviously, this isn't always possible, but if it is, you will see significant performance boosts. So minimize the looping. Secondly is minimize the number of invokes. Again, we have an anti-pattern of very chatty integrations. If you find yourself with very chatty integrations, review those endpoint interfaces that you're using, see if there's a better way of doing it. For example, is there a bulk interface that you can use? Is there a coarser grained API that you could be using to reduce the number of invokes? Because each invoke adds to your latency and so slows you down. Look at ways to process multiple messages at the same time in a single orchestration. So for example, if it's possible to have the client application send you multiple orders instead of one at a time, your performance is going to improve because you've only got one trigger taking place, and then you're able to go through multiple orders and hopefully even push them into the target systems of record as a single message. So applications such as Salesforce, Fusion ERP, NetSuite support batch interfaces or bulk interfaces that allow you to submit hundreds or in some cases even thousands of records in a single call. This again will significantly reduce the time taken in the integrations. And on that note, it's worth observing that we have enhanced the Salesforce adapter over the last few months to support the Salesforce bulk APIs, which support, I think it's up to 10,000 items in a request. I think that's the number. Either way, it gives you a significant performance boost instead of making multiple individual calls. Also, another common area that we see causing integrations to run slowly is payload logging. First of all, when you activate the integration, typically for development, you will want to enable activity stream logging and payload logging so that you can make sure that the integration is behaving as you expect. When you move into production, often you will want to turn these off, both for performance and also to avoid logging any sensitive information. If you do need to log some information, we recommend that you use the explicit log function built into OIC. This still writes to the activity stream, but you have options to control when it's written, and you also have more control over what data goes in there. You choose the data that goes into the explicit log functionality in OIC. So the recommendation here is don't turn on payload logging or activity stream logging. If there are specific points in your integration that you need to know that they occurred, or you need to record for audit purposes some of the data, use the log function. So finally, OIC does have some parallel processing constructs built in. First of all, though, let's start with the bad news. Synchronous integrations today only have a single flow of control through them. There is no parallel processing within a sync integration, a request-reply integration. In order to get parallel processing in a sync integration, you can call multiple async integrations to get that parallel processing effect. So this is similar to the pattern we talked about earlier, where you want to break apart the work you have to do in a request reply and the work that can be pushed off later. Pushing it off later also enables that work to be done in parallel through async integrations because they are automatically run in parallel. So that's the first thing, is look at using calling async flows from a sync one to get parallelism. The next one is within file processing. We highly recommend that in most file processing cases, you should be using chunked read, record level reading, so that you're not reading the whole file. And in fact, we have a limit of 10 megabytes on the file that can be materialized at any one time. And the chunked read allows you to read files up to 1 gigabyte in size. There is, when processing, the option to say, hey, I want these records to be processed in parallel. So unless there are strict ordering requirements, this is a good way to reduce the runtime of file processing by running them in parallel. Obviously, you can't always use this flag. It depends on your use case. Sometimes you have to submit the records in the order they appear in the file. But if you don't, parallel flag can significantly reduce your run times. Also, for both scheduled orchestrations and asynchronous no reply orchestrations, there are options on the looping to run those loops in parallel. Again, it depends on your use case, whether that's going to be allowed. But if it is allowed for your use case, again, that's a significant performance boost that will reduce the amount of time that you're spending processing the records. So these are features that we've talked about that are all built into OIC. What I'd like to talk about next are ways in which we can improve the performance through using other parts of the OCI ecosystem. One of the great benefits of using OIC is that we are not just an integration platform, but we sit as part of the larger OCI cloud platform and can take advantage of some of the features in there to improve our performance. First of all, number of customers in the past have been calling OIC APIs to figure out what are their response times for their endpoints. How many times has an integration been called? And they've often integrated these then with Splunk or with Oracle Management Cloud or with other management systems. The problem with this is that they're hitting the same OIC instance that is trying to process their messages. Middle of last year, we added a capability to push lots of metrics from OIC into the OCI metrics service. This is important for a number of reasons. First of all, it means that you no longer have to try and retrieve this data from the activity stream and do lots of processing on it yourself to try and figure out what was going on. We now actually give you the numbers that you typically want, such as endpoint response times, integration response times, and counts for integrations, failure counts, etc. Those are all available through the OCI metrics service for your OIC instances. The metrics service also allows us to set alerts. So, for example, if a particular endpoint response time goes up, we can have an alert set on it. Or if we get an error count that goes high, we can set the alert in the metrics service. Again, this gives us much finer grained control without putting load on our OIC instances. So OIC can focus on moving your business messages, and your management side can be moved into OCI. We're hoping to come out before May, but in the worst case, by May, we will have the ability to send our activity streams to the OCI logging service. Again, this will remove the need for downloading the activity stream from OIC. So this is something that customers have been doing either for audit purposes or for log analysis purposes, where they've been pulling them down by making multiple calls to OIC to download the activity streams. This puts a load on OIC. Moving it to the logging service has a couple of benefits. First of all, we've offloaded the load from OIC. And secondly, we have given you more options in the logging service. So in the logging service, you can search and filter for things instantly. You also have the ability through other OCI services to process that data. So we have a service called the OCI Service Connector. The primary client of source of data for that is the logging service. And then from downstream, we can push it into Splunk, into other Oracle services. So great way of offloading and getting better data at the same time. And how often do you get a performance boost and better information? But offloading gives us that. The other things is that we can take advantage of other OCI services. For example, we can do complex processing in functions. Instead of trying to do complex processing in JavaScript, which can be a little clunky and awkward for some very complex things, we can use, for example, we could deploy a Python function in OCI functions and then call it from REST or other specific adapters. Again, we can take advantage of the event service within the event streams service in OCI to do some pre-processing on events for us so that we don't get overwhelmed. We've got customers that have used OKE clusters to set up very small, simple pieces of code to do caching or split join type processing. And so, for example, the customer that's doing 1 million messages an hour, they actually have a small OKE cluster where they deployed an application that takes a request from the integration and then makes multiple calls in parallel, gathers them together and sends the single response back. Now, this is a feature that we will be adding to OIC in the future, but it gives you ways to extend OIC for things that aren't there today that you might want. And all of those can improve your performance. So those are some of the things that can improve performance that we've talked about. There is a great section in the Oracle documentation where we document common integration pattern pitfalls and design best practices. So if you search for that in the Oracle integration, you'll find it useful and helpful. And several of those patterns we've talked about today. In addition, always follow the Oracle integration blog. Couple of useful things related to performance. One is how to invoke an OCI function from Oracle Integration Cloud. It may be that you can do some things more effectively in custom code than you can in OIC. So rather than saying that's a bad thing, we embrace it by making it easy to call OCI functions. Similarly, there's an article on the blog about using global variables and data stitch to log request payloads or portions of request payloads. Also, there's a sample split join application on Docker Hub. It's not supported by Oracle, but it shows you how you can call a service from OIC, split it apart, do parallel calls, gather the results, and send the response back. And it's a completely generic service, and that's on Docker Hub. And the source code for that is fully available on GitHub. So with that said, what I'd like to do now is thank you for your time and wishing you good luck in optimizing and getting highly efficient and scalable OIC solutions, and hand you back to Jürgen.
Anthony, thank you for the wonderful presentation and the impressive numbers on scalability. If you have implemented successful Oracle Integration Cloud as an Oracle partner and you have customers who have similar performance numbers, please let us know. We are very interested to connect to you. If you would like to send us an email, please send it to Neil Kominski or myself. To wrap up today's call, if you're not yet a member in the partner community, please make sure that you register now to receive our monthly newsletter with all the content like the upcoming hands-on trainings and future community webcasts. If you would like to try Oracle integration, please feel free to use the free trial or use our playground, which is available for you as a partner as a shared environment. Today's webcast will be available at the Oracle Video Hub, so watch the on-demand webcast there and please subscribe to receive alerts. For more information, like Anthony pointed out, please visit the integration website, and there's also the link to his white paper. With that, we would like to open up for questions and answers. To summarize many of the questions and answers, Neil is with us. Neil, what are the most important questions for the benefit of everybody?
Okay, the most important questions, I suppose, like the couple of unanswered ones that I've left over for Anthony are things that we get quite a bit from folks who have been used to using SOA Suite, and things like the ability to change the timeouts for adapters. So Anthony, in OIC, we do not have this.
No, and so currently we are looking at different limits within OIC and looking at which of those limits we might want to perhaps allow to be customizable. And so some of those things include potentially timeouts for integrations. For example, the customer that I mentioned using the point of sale. If the point of sale doesn't get a response in 6 seconds, it automatically resubmits the request. Obviously, any of those point of sale integrations, if they run long, it would make sense for us to kill them. So that's certainly one thing, is that type of timeout. We are also considering how we could enable timeouts for invokes. That's certainly an issue today. And we've sort of set an arbitrary limit, for example, when using the adapter of 4 minutes. And there's certainly no way to increase those today, but we are looking at, can we make them shorter for certain customer request, and that would allow you to fail fast. So don't expect to see timeouts increasing, but do expect to, at some point in the future, to see the ability to set a shorter timeout.
Okay. Now, one of the questions that we get quite a bit is to do with the database adapter as well. And this, now, so just a variation on this theme, where we're calling something at database level a store procedure, and it's doing number crunching, and it just takes a hell of a long time. Now, I suppose, Anthony, the same thing there is like what I often say to customers is, see if there's any way you can re-engineer what's happening on the database to reduce this time. But otherwise, there's nothing else we can do.
No, there isn't, because the calls to the database adapter are always synchronous, their request reply. And so that we don't want to be hanging those around forever. And a pattern that we have seen successfully used without touching the source, and it's almost always a stored procedure that causes this problem. It's very rare that it's a large select statement. It's pretty much universally a stored procedure, as you say. And what we have seen a solution to this is to make it a two-stage process, where first of all, the integration, where you create a wrapper stored procedure that basically puts the request onto AQ. And then it's taken off AQ automatically within the database. The database runs the stored procedure, and then it puts the response back onto a queue, for example. And so we have seen that pattern that allows the integration to kick off the work and then to go to sleep and wake up every 30 seconds or 60 seconds and see if the response has arrived and then deal with it. So that's a pattern that we've done, but we are unlikely to increase the database adapter timeout. So you will end up having to do something like that pattern.
Well, that's great. Now, I think, Pradosh, that answers your question, and that's a very good alternative approach then. Now, another question we have here from Milind is it advisable to use OIC for data files over 1 gig? Now, he's talking about 200 files a day, and I've asked him then, do we need to actually process these files? And he says, yes, yeah, and the need is to transform them into FBDI format. So we're talking about 200 files per day over 1 gig. You were mentioning there, okay, the chunk read and things like that. So this should be doable.
Well, today there is a limit of a 1 gigabyte file size. So if the files are over 1 gig, then we cannot process them today in OIC.
Oh, sorry, I thought Milind, I thought you were saying up to 1 gig. I see here, yeah, it's over 1 gig. So we cannot do that, yeah. So net.
And so for that, we recommend using the data services integrator. And we're currently working with the data integration team to better align application integration and data integration, specifically for these sort of use cases where they've kind of got a foot in each camp.
Just a question here on this, Anthony, when we're just talking about this, we have many partners who are involved with customers who are moving from EBS to Fusion ERP. And they're adopting, say, OIC then, and they have this period of coexistence. But for the initial loading of data into ERP, this is a good idea to use ODI for that. And then OIC takes over for, after the initial load, OIC takes over for the business processes, correct?
Yes, that's certainly one option. If the files are less than 1 gigabyte, then yes, you can do it in OIC, and it's kind of a one-off sort of thing in OIC. But if they're going to be more than 1 gigabyte, absolutely look at ODI and the data services integration. So
I think that's very important for partners. Is like I've seen this with some customers that I've been involved with. It's often an either or. It's data integration or application integration. But many cases it's both. And maybe for the data integration is purely for doing the initial loading or whatever, or for processing extremely big files. But again, as partners, like you are the ones who would be able to advise your customers accordingly that these two, they augment each other. They don't compete.
Now, also, Phil Wilkins, hi Phil, thanks for your comments, made an interesting comment that you can also potentially stage to a database and then pull through the DB connection for very large files. Yeah. Now, again, you've got to question whether OIC is the right tool for very, very large files, even though you can get around it using the DB. And just to amplify that, there is a capability now in the database to read from storage cloud and import data directly from storage cloud. Mm-hmm. And so that then allows you to bypass the gigabyte limits in OIC, but you would still be pushing a large number of messages through, and you need to sort of assess whether a data integration solution might be better.
And it could also be better, it could also be cheaper, Anthony, when we're talking about that.
Exactly, yes, I agree. We want to give the best solution for the customer and the most cost-effective solution for the customer. And we prefer to have a happy customer than extract a few more dollars from them, only for them to be really upset at us and never want to use us again.
There's another question here from Luke Lawler. I hope I'm pronouncing it the Irish way, Luke, your surname, so I hope it's correct. But what advice do we give customers who are preparing to go live and they don't know the volumes? Now, for example, the customer who experienced 40K messages in the first hour of production. Now, I think for most customers, they do have a good idea of what they should be doing. And I've seen with other customers, what we've done is we've actually started off on 1 or 2 message packs and then looked at the usage metrics and then moved, added more message packs if required. But Anthony, do you have any heuristics as well on this?
The only thing I would add to that, Neil, is to say make sure they have realistic tests before they go live. This is the biggest complaint from Jim Bowl, who leads our customer support organization for Oracle integration, is that customers go live without doing proper load testing. And so load testing, you should make sure that customers understand that load testing is not a luxury, it's a requirement.
Okay, so this is really it. I see, Jürgen, we're coming up to 17:28, so we're just coming up to the hour. So I think that's it. And
thank you very much.
Thank you all for your questions, folks, and let's stay in touch.
That was great, Anthony. Thank you very much. Thank you, Neil, for answering all the questions. As we run out of time, please feel free to use our partner Slack channel to continue to ask your questions. We have a team who is monitoring that, and you can find the link in the chat. It's rebrand.li/askOIC. I would like to say thanks for everybody who did attend the webcast, and we would like to welcome you also next month, May 30th, for the next community webcast. Thank you very much for attending. Thank you, Anthony and Neil, for presenting, and looking forward to welcome you next time.